In this video, I would like to perform the third conductometry experiment of the SYBSc syllabus. The experiment is to determine the dissociation constant of weak acid conductometrically. The name of the experiment is to determine the dissociation constant of weak acid conductometrically. So what are the requirements for this experiment? We require saturated solution of benzoic acid. So already I have taken some solid benzoic acid and it is added into the water. You can see the benzoic acid, it is not soluble in water. Benzoic acid, it is a weak acid. It is sparingly soluble in water. So I would like to determine the dissociation constant of this benzoic acid using conductometrically. So first of all, I would like to filter this solution now, because to prepare the solutions of the benzoic acid, I require this solution. So first of all, I would like to filter this solution, and with the help of the filtered benzoic acid solution, that is a saturated benzoic acid solution, I am going to prepare the other solutions. Now what are the requirements? Saturated benzoic acid solution, 0.1 normal KCl solution to determine the cell constant. Whenever we are doing the conductometry experiment, it is necessary to determine the cell constant. So we require 0.1 normal KCl solution to determine the cell constant. In this experiment, I require the 0.1 normal succinic acid solution. So this succinic acid solution is required to standardize the sodium hydroxide solution. So burette solution, it is sodium hydroxide, 0.1 normal sodium hydroxide solution, it is already filled in the burette solution. So first of all, I would like to standardize the 0.1 normal sodium hydroxide solution. This 0.1 normal sodium hydroxide solution is required for us because to determine the concentration of this benzoic acid solution. Now this saturated benzoic acid solution has an unknown concentration. So what will be the concentration of this benzoic acid solution? For that purpose I require 0.1 normal NaOH solution, and to standardize the 0.1 normal NaOH solution we require this 0.1 normal succinic acid solution. So I have prepared this succinic acid solution by taking 0.59 gram of the succinic acid, and it is dissolved in water, and that solution is diluted up to the mark here. So this is 100 ml of 0.1 normal succinic acid solution. So now first of all I am going to standardize the sodium hydroxide solution. So I would like to take 10 ml of 0.1 normal succinic acid solution here in the conical flask. So this is succinic acid solution. So 10 ml of the succinic acid solution I want to take here. So in a conical flask I have taken 10 ml of the succinic acid solution, 0.1 normal succinic acid solution. I prepared the succinic acid solution. Now I would like to standardize the sodium. So this is the first part of the experiment, standardization of sodium hydroxide solution. Now I would like to add the phenolphthalein indicator into this, 2 or 3 drops. So 2 or 3 drops of the phenolphthalein indicator added here into the succinic acid solution, and I am going to titrate now this with sodium hydroxide solution from the burette. So the color change, it is colorless to pink. are titrating the solution with sodium hydroxide. Succinic acid is the acid, sodium hydroxide is a base. So the end point of the titration, it is colorless to pink. As I have taken 10 ml of the succinic acid solution, so the approximate reading should be equal to 10 ml. For 10 ml of the acid, we require 10 ml of the NaOH solution. So let us see here. The color change should be there, colorless to permanent pink color. So the burette reading, it is 10.5 ml. Okay. So for 10 ml of the succinic acid, we require 10.5 ml, that is burette reading. And with the help of this burette reading, we can determine the normality of the sodium hydroxide solution. Normality of the sodium hydroxide solution can be determined here. So standardization part is completed here. Now the second part I would like to do this, that is to determine the molar concentration of the benzoic acid. I have prepared the saturated solution of the benzoic acid. Now I would like to determine the concentration of the benzoic acid. So this is saturated solution of the benzoic acid. Now I would like to take 25 ml of this solution in the conical flask. In the meantime, I would like to fill the burette with sodium hydroxide solution. This is 0.1 normal sodium hydroxide solution. And with the help of the sodium hydroxide solution, I would like to determine the concentration of the benzoic acid solution. So I would like to take the benzoic acid solution here. So this is saturated filtered benzoic acid solution, and I want to determine the concentration of this benzoic acid by titrating with NaOH. The end point is same here, colorless to pink. The end point is colorless to pink. So with the help of the burette reading, we can determine the concentration of the benzoic acid. Saturated solution has an unknown concentration. So first of all, I would like to determine the concentration of the benzoic acid, saturated benzoic acid solution. So I have taken 25 ml in the conical flask. I would like to add the indicator here, phenolphthalein, 2-3 drops. The indicator should be added here, and I am going to titrate this solution with the sodium hydroxide solution. So you can see here the color change, it is colorless to pink, and with the help of the burette reading, we can determine the concentration of the benzoic acid. Concentration of the benzoic acid. Color change, it is colorless to permanent pink color. Colorless to permanent pink color. Right. Colorless to permanent pink color. So the reading, it is around 6.7. 6.7. Okay, reading it is 6.7. Burette reading, it is 6.7. So with the help of this burette reading, we can determine the concentration of the benzoic acid here. That is the calculation part. So once we know the concentration of the benzoic acid, then with the help of that molar concentration, I have to prepare the other solutions. Okay, I have to prepare the other solutions.